I am not encouraging or advising anyone to modify their firearms. This is for entertainment and educational purposes only. What's up, everyone? I hope the last video provided a good baseline of knowledge regarding how the trigger system works in this Archon. If you're not familiar with this trigger system, I would recommend watching it before proceeding. A link to a playlist of all my Archon Type B videos is in the description. This video will be about improving this trigger. We will establish a baseline of trigger action, then we'll get into some spring tuning, then polishing of all the components, then modifications to reduce creep and take out some overtravel. I'll be taking measurements along the way to isolate what gains are to be had by what modifications. It's going to be a lot of fun. Let's get into it. Let's establish our baseline of the trigger. I do have about 200 rounds through it now. I would consider it broken in. The trigger did smooth out a little bit. For all the weight measurements I take of the trigger during this whole video, the firearm is cleaned and lubricated. For all my weight measurements, I'm going to be measuring in the middle of this lower flat section, kind of where like the middle of my finger goes. First, let's look at the take-up weight. Two and a quarter. About 2¼ pounds. Next is the trigger break weight. Right out of the box, I measured it around 5 pounds. Around 5 pounds. I won't be making any adjustments to the distance the trigger shoe moves to disengage the safety, nor the pre-travel. The amount of take up this trigger has feels good to me. I measured all my trigger action distances in the same way. Calipers in between the trigger and trigger guard held at the same mark on the trigger and the trigger guard for each measurement. I got about 2.5 millimeters of creep from the wall until the striker releases. And I got about 2 millimeters of overtravel. The reset is the sum of the creep in the overtravel measurement plus about 1 millimeter. While these measurements may not be the most accurate, I think they are good enough to give us a baseline for comparison and a way to quantify changes and improvement. I bought this recoil reduction kit from Range 6 for 120 bucks. I don't really care about these DPM recoil systems, in my opinion. Based on my own testing with one of these kits in a P320, these don't do much in terms of changing felt recoil, especially if the pistol already has a multi-spring recoil assembly. This may help if I port the barrel. Since I have it, I'll likely do some testing. I'll let you know if I end up using any part of this kit. I really only wanted this reduced power striker spring for testing purposes. Fully pre-cocked striker systems are much less sensitive to striker spring changes, so I don't know how much this will do for me in terms of reducing trigger break weight. Maybe it's just wishful thinking on my part. In the kit description, there are no claims of reduced trigger break weight, only that it makes slide manipulation easier and further enhances recoil reduction. Let's install it in the pistol and see. Right around 5 pounds. Right at 5 pounds. No appreciable difference in trigger break weight with that lighter spring. There are two other springs that play a big role in trigger action: the sear spring and the trigger return spring. The sear spring only affects trigger break weight. The trigger return spring will affect take up and break weight and reset positivity. I did some very rough measurements of spring rate, and I got around 9 to 10 pounds per inch for the sear spring and about 18 pounds per inch for the trigger return spring. Don't take those numbers to the bank. There is a kit for the Arsenal Strike 1 offered through American Precision Firearms, who imports the Strike 1. It comes with a new sear spring, and trigger return spring in addition to a new trigger assembly. I would venture a guess those components may fit in the Archon, but I didn't want to spend another $130 to find out. I went on McMaster, which has thousands of compression springs, and I surprisingly couldn't find an option in the size I needed with a reasonable spring rate for either spring. I ended up ordering a few options for the trigger return spring from McMaster, but none of them worked out. I looked around for another spring supplier and came across Century Spring. They had many more options than the McMaster and better filtering tools. Here are the parameters of the factory springs that I used to select replacements. My measurements of the factory spring rates were rough, but hopefully the variety I purchased will give me a good range to test with. There are too many combinations of sear and trigger return springs to test, so I'm going to test each spring individually and see how that affects trigger weight. I do need to mention that I got tired of waiting for springs and went ahead and polished all the trigger components. In the polishing section later in the video, I show that the polishing work did not affect my trigger take-up or break weight. Would it have affected this testing? Maybe, but I don't think by much. However, it might affect operation, specifically reset reliability with lighter springs. I'll elaborate on this more in a little bit. You didn't need to see me do all the testing, so here's a chart of the results. I will refer to each spring by their Century Springs SKU and advertised spring rate. The trigger return spring will affect take-up and break weight, so I captured both those changes. The sear spring won't affect take-up weight, so I only am showing the break weight change for those. I had to cut V41 to length. 11 pounds is too light. The reset was very unreliable. Take-up was around 1 pound. There was a half-pound reduction in break weight. AA42 at 13 pounds produced a 1.25 pound take-up, but the reset was marginal, not quite reliable. Break weight dropped by a half a pound. B8-8 was a wash. The spring was too short, resulting in too little preload. The take-up weight was a little bit below 1.25 pounds and would not reset at all. The break weight was 4.25 pounds. 2935 needed to be cut to length. It dropped the take-up weight to 2 pounds. The break weight didn't change. This leads me to believe the factory spring rate is probably 20 to 21 pounds, a little heavier than my initial guess. So it looks like the trigger return spring weight cannot be reduced much, or the reset becomes unreliable. Any take-up weight less than or equal to about 1.25 pounds will likely correspond with compromised reset function. The trigger return spring did not reduce break weight that much either. You may get a reduction of a half a pound at most before reset function is impacted. I think the 14-pound spring might have functioned if it was longer. It looks like Century part numbers 3633 and J80 might be good options at 14 pounds per inch. I don't know why I didn't order one of those. I ordered a 16 pound, but unfortunately it is 4 to 6 weeks out. That would have been a good one to test. All right, replacement sear springs. 60627 dropped the break weight to about 4.25 pounds. M121 to 4.5 pounds. LL82 to 4.75 pounds. I had to cut one coil off that spring. And H57 produced the same break weight as the factory, so I am guessing the factory sear spring is probably around 11 pounds per inch, again a little higher than my initial guess. All these sear springs function reliably. Even the lightest 3.3 pound spring had positive sear action. You may be able to go even lower, but I might start worrying about reliability. There may be 3/4 pound to a pound of break weight reduction to be had with a lighter sear spring. Of course, any number of spring rates and different free lengths, which would result in different preload amounts, could be played with for further tuning. Century Spring has an insane selection. Rain 6 was nice enough to sell me their reduced force trigger return and sear springs that they install with their Stage 3 trigger job service. These are not listed on their site, and I don't think they generally sell them separately, so I really appreciate this. Big shout out to Rain 6. I tested these and added the results to my chart. Let's take a look. The trigger return spring dropped take up to 1.25 pounds and dropped the break weight to about 4.5 pounds. I was getting a reliable reset with this spring. The sear spring dropped the break weight to 4.25 pounds. I then installed both springs. Take-up weight was the same and break weight dropped to 3.5 pounds. It seems the drop in break weight with both springs installed is a little more than the sum of the reductions due to the individual springs. Here are the measurements I took of the Rain 6 springs and my guesses at their spring rates. These rates are based on the trigger weight reductions and squishing springs in my fingers. I did the same rough testing I had done on previous springs, and the calculated rates were close to my guesses. The trigger spring felt very similar to the 14-pound spring I tested, but this Rain 6 one is the same length as the factory one, not short like the other 14-pound spring I tested. So I think that was what made the difference in reset reliability. The sear spring felt a little bit lighter than the 3.3 pound spring I ordered, maybe 2.5 to 3 pounds. The thing with springs for a given material and manufacturing method, like hot wound or cold wound, if you have the same OD, wire diameter, free length, and number of coils, the spring rates are going to be pretty similar. This made finding equivalent springs easy. The Century Spring part number 3633 appears to be the closest to the Rain 6 trigger return spring, but it will need to be cut to length. Part number 60628S is closest to the Rain 6 sear spring. Let's wrap up this spring tuning section. A 20% reduced power striker spring didn't affect my trigger weight at all. It seems that about a 14 pound per inch trigger return spring of equal free length to the factory one is about as low as you can go before you start running into reset function issues. This may drop your take-up weight by up to a pound and reduce brake weight by up to half a pound. In my correspondence with Rain 6, they mentioned that if their springs are installed, it generally results in a soft, non-tactile reset unless other work is done to get it to function reliably. They didn't tell me what that other work was, but I'm guessing it's polishing. A few more moving parts in this trigger system results in some extra friction between components. I am guessing the reduced spring force has a hard time overcoming that friction for a positive reset unless the components are polished. I had a reliable reset with the lighter sear spring because I polished my trigger components, but you may not in your pistol if you didn't. It seems that the sear spring can be as low as maybe 2 to 3 pounds per inch at the same free length as the factory one and still function reliably. This may drop your brake weight by up to 3/4 of a pound. If you swap out both these springs for reduced power alternatives, you may see the trigger brake weight drop by a little more than the sum of the two individual reductions, maybe up to a total of 1.5 pounds. I was pretty much able to figure all this out with the testing of the Sentry springs. Then when I got the Rain 6 springs and tested and measured those, that was a nice little bit of confirmation. Once again, here are the Sentry spring part numbers that I think are a good substitute for the Rain 6 spring. 3633 needs cut to length, and 60628S should be a drop-in for the sear spring. 16 and 19 pound trigger return springs will be in between the Rain 6 and factory springs. Here are the Sentry spring part number for those. Both these will need to be cut to length. 5 and 8 pound sear springs will be in between the Rain 6 and factory sear springs. Here are the Sentry springs part number for those. The 8 pound spring needs to be cut to length. Unfortunately, I couldn't find any alternatives for the ones I listed that didn't require cutting. If you're cutting any springs, I would recommend putting the closed end that you didn't cut towards your plunger. I've also identified springs I believe are good replacements for the factory springs should you ever need them. You can buy a spring kit from PTR, but it doesn't look like it has a trigger return spring. Sentry springs part number A15-6 for the trigger return spring and H57 for the sear spring. I have identified multiple ways to add overtravel adjustment or limits to this fire control unit. I'm going to go over them before explaining why I went the route that I did. Let me know if I missed something or you see another way it could be done. I did have a viewer on my channel share some information on how overtravel is limited on the Arsenal Strike 1 and what Rain 6 did to his Archon trigger system. Shout outs to him. I appreciate the info, man. We could put a big ass long set screw through the trigger shoe to stop up against the grip module. That would look really, really stupid. We can stop the rearward travel of the trigger bar in a few ways. We could put a stop somewhere back here. I thought maybe a 3D printed piece, but there wasn't enough space between this and the inside of the grip module. We could limit the rearward travel of the trigger bar by putting a set screw here or right here, like I did. We could add material between this trigger pivot bar in the center of the shoe and the stop on the FCU right here. Maybe a tiny weld on either side and file it down. We could put a set screw in the back of this pivot bar. It would need to probably be 2mm diameter or less because this is only 3mm wide. According to that viewer I mentioned earlier, some of the Arsenal Strike 1 competition trigger kits have a set screw right here. If we look at this trigger kit I showed earlier from the Arsenal Strike 1, it looks like maybe the back of the trigger pivot bar protrudes a little further. I thought about a bent piece of shim stock or sheet metal around here to add thickness right here. Maybe a set screw fired this way, kind of into this gap to hit on the back of this trigger pivot bar. Maybe one in this area. It would probably be kind of in the feed ramp area, so that's probably not the best option. The plunger for the trigger return spring could be modified or a new one machined to provide some sort of hard stop in the spring pocket. You wouldn't want to limit the travel by installing a longer spring in here that would close or bind the coils to provide a hard stop. Closing compression springs during cycling makes them fatigue extremely fast. The viewer I mentioned, if I interpreted his comment correctly, said that Rain 6 installed a set screw right here. The plunger tail would likely need to be shortened a little bit. This 2.5 millimeter hole that creates the shoulder for the spring is the tap drill diameter for M3 by 0.5. This face right here goes up against the inside of the grip module. That may need to be relieved a little bit, or possibly you could drill a hole through the grip module and access this screw through the trigger guard. The top of this trigger pivot bar right here contacts the FCU in this square little cutout around the spring pocket. Material could be added to this surface of the trigger pivot bar and filed down to a new stop. Lots of ways to skin this cat. Let me explain why I put my overtravel screw right here. Easiest option seemed to be tapping this hole for an M3 set screw. This would be a gamble on my particular fire control unit that I wasn't willing to take. You can see this right here. That is part of the spring poking through on the bottom side of that hole. There is no thickness on this side of the hole for threads to be cut. The cross section of the hole might look like this. If I were to run a tap through here, it would probably break out from here around to here, only leaving me with 3/4 of the circumference of this hole threaded. The set screw might not stay put or blow out eventually. Then I might not be left with a full shoulder to support the spring, even though the spring would still likely be captured by the grip module right here. I'm not saying this is the case with all FCUs. There's probably some manufacturing tolerance around the position and angle of this hole and the depth of the counterbore for the spring. So other FCUs might have enough meat on this back side right here to thread this hole for a set screw, but this was definitely a no-go on my fire control unit. Drilling and tapping the trigger bar right here. I even made a jig that would hold the trigger bar in a vise for easy drilling. I was a little bit worried about weakening the trigger bar by removing too much material here. It probably would have been fine. Drilling and tapping the back of this trigger pivot bar would have been really difficult. Very small diameter blind hole. I decided to drill and tap here. Straight shot to the back of the trigger bar, not a structural component or area of the FCU, plenty of material around it, and depth for the 2.5 millimeter threads. If I screwed it up somehow, it wouldn't affect the function of the pistol. It was relatively easy to drill and tap and not very sensitive to positional changes if my drill bit wandered, which it did a little bit. There are a few issues that I identified before I did this, none of which were a big enough deal to stop me. One, this is not adjustable with the FCU in the grip module, but none of the other options really were either. Two, the trigger bar moves slightly as it is disconnected, meaning that the trigger shoe will move a tiny bit too, but I don't even notice it when I pull the trigger and cycle the action. Three, this is where the magazine comes into the fire control unit, so I needed to make sure the head of this screw didn't interfere. All right, limiting pre-travel. I'm not going to do this. I like the amount of pre-travel the trigger has, but I suppose it could be done. The shoe pivots into the trigger pivot bar, then the take-up is from there until the trigger bar hits the sear back here. There isn't much take-up, so it makes it difficult. You see this little gap that opens up between this upper trigger cross pin and the top of the trigger bar here? One way would be to add material between this cross pin and this back side of the trigger pivot bar, or install, a set screw in the pivot bar up here. If you wanted to limit the distance that it takes to pivot the trigger shoe to disengage that safety, you can see the hard forward stop of the trigger shoe is between this face and the trigger pivot bar. So you could add some material, maybe a little weld or something, and file it down to space that trigger shoe a little bit forward off that trigger pivot bar. Let's talk about reducing creep in the trigger pull. Once the wall is reached, creep comes from the distance the sear needs to move to release the striker. I can see the wear mark on my sear face where it interacts with the striker, and I can get a rough measurement, and it looks like I have about 60 thousandths of engagement. That seems a bit excessive to me, and this trigger has a mile of creep, and I don't think it's necessary from a safety standpoint. I measured some of my other striker fired pistols and saw between 30 to 40 thousandths of engagement. My M&P 2.0 with the Apex trigger kit has as little as 15 to 20 thousandths. There is one way to reduce creep. That is to reduce the sear to striker engagement. Removing material from this edge right here. As the sear pivots this way, it will let go of the striker earlier, reducing creep. If the striker releases earlier, you can also adjust out more overtravel and get a shorter reset. Generally, I wouldn't recommend doing this, especially depending on the use case of the pistol. It's best to leave all the factory geometry and safety margins intact. I'm going to take 10 thousandths off my sear for a start and see how much that reduces creep. This is easy to measure, like so, and adjust. Started out at 82, now I'm right at about 72. So I know I reduced the width of this sear face by really close to 10 thousandths of an inch. That reduction in creep is noticeable. I'm not going to go too crazy with this. I think I'm going to take another 5 thousandths off and call it good. We were at 82, now we're at 72. I'm going to go ahead and take it down to 67. There we go. Now I'm measuring about 1.5 millimeters of creep using the same measurement method I did before. I don't feel comfortable taking any more material off that sear, so it is what it is. It's a noticeable improvement. Now that I've done that, I can do my final adjustment on my overtravel screw. I'm not going to show the polishing process. You can skip to the next section knowing that I pretty much polished any interface where any two components related to the trigger system interact. If you want the nitty-gritty details of what I polished where and why, then go ahead and watch this next section. There's not a lot to do in terms of polishing trigger system components in the slide. This is the striker, and it looks like it possibly has an electroless nickel coating on it, maybe NP3, so I'm not touching that, don't need to. This is a little disconnector rail, and you can see it's already got a little wear mark on it, but this already has a really nice smooth finish and a nice radius right here on the transition between these two faces, so nothing is really needed there. The striker spring, shuttle tube, whatever you want to call it. Again, it's smooth. There's no sharp edges on it. I don't really need to do anything there. This is the striker block lever. It's a MIM part, so I knocked down high spots on the bottom of it because there was some remnants and flashing and high spots left from the injection molding process. That pivots in there like that, so that will just reduce friction where it pivots on the slide. This angle right here in this face is what interacts with the trigger bar as the lever gets disengaged and pushed to the side. I very carefully broke the edge with a little stone between these two faces and then put a polish on them. I also very gently spun some rolled up 1000 grit in this hole right here where it pivots on the pin of this disconnector rail. Polishing this striker block lever is going to smooth out the take up of the trigger pull. Wanted to take a look at this before I modify it. As this trigger link or trigger pivot bar, whatever the hell I've been calling it, is coming forward and compressing the trigger return spring and plunger, the corners of that little bar are hitting right here and right here on that square cutout that goes around the spring pocket. And I actually feel this in the take up. I can feel when those contact these edges and then start scraping along them. So what I'm going to do is this edge right here and this edge right here are going to get a shallow chamfer on them, and then I'll break those edges and polish this whole tip right here. This area of the trigger bar right here and right here are what interact with that striker block lever, but you can see there's a little burr on that edge right there. So I can catch my screwdriver tip on that burr. So that burr is going to get taken off. I just wanted to show you that before I did it. With a fine stone, burr's gone. It's nice and smooth. I have a continuous face here, continuous face here. I'm going to break the edge between these two faces just a little bit, polish it. Trigger bar is done. I knocked down some high spots and broke some rough edges along the inside of the trigger bar. You can see here where it was starting to leave a wear mark as it slid back and forth. I got into this little tiny groove where the trigger bar support spring goes and very gently smoothed it out with some folded 1000 grit. Broke that edge, polished both of these faces where they interact with the striker block lever. broke some edges, and polished this face right here. This is what slides on the underside of the sear as it comes back forward. This should smooth out the reset. Smoothed out and polished the top of this. This right here is what the disconnector rail rubs on and pushes down to disconnect the trigger. And then of course, this little area right here got polished. They already had a little angle ground on it, so I left that. I just broke the edges between the angle in the center and this face, and then polished that. And this is what interacts with the little fin on the sear to push it out of the way. You can see my little chamfer there, and I broke that edge, chamfer there, broke that edge, and then polished all the way around that little front piece right there. Let's look at this sear. Knocked down some high spots on the bottom where it pivots, and right here too where the trigger bar slides under it as it resets. Polished this little area of that fin. This is where the trigger bar pushes it to pivot it out of the way. I broke the sharp edge very, very slightly right here where I narrowed this sear face and then polished the whole sear face. I'm not going to do anything on the trigger cross pins. Those have a nice smooth finish on them. Polished the tip and all around the edge of this trigger return spring plunger so it will slide very smoothly in the spring pocket, and also where it interacts with this trigger link or trigger pivot bar. I polished the trigger return spring plunger. I did not polish the sear spring plunger. When we polish things, we obviously take away a corrosion resistant coating. That's fine here because this is easy for me to oil. All of this stuff right here, easy for me to oil. I'm less sure that I can keep this plunger well oiled without removing the FCU from the grip module. I'm not interested in removing the FCU every time I need to clean and lube this thing. Some of the coating will wear off where the plunger contacts the sear. I don't want to remove any more than that. Check the take-up weight. Before it was 2.25 pounds. Still around the same, 2.25. Maybe a hair under 2.25. Not much change there. So right now we have the factory striker spring installed. Right at 5 pounds. Hair under 5 pounds. So what did the polishing get done for us? Nothing really in terms of take-up weight or trigger break weight. It made a noticeable difference in the smoothness of the trigger. It feels much better now. The take-up is much smoother, less gritty, less stagey. The creep is much smoother and it rolls through it quicker after you hit the wall. And the reset feels more positive and it's very smooth. I've been touching on some of the safety and operational concerns associated with these modifications throughout the video, but I want to summarize them all in one place as we wrap this up. Reducing creep by reducing sear engagement surface width or installing lighter sear springs may compromise sear engagement. Reducing the pre-travel distance is risky. There isn't much pre-travel to begin with, and it could disable the trigger shoe safety or partially disengage the sear. I would not recommend doing this. Installing an overtravel adjustment screw could prevent striker release if the adjustment moves, or the screw may come out and lodge itself somewhere and cause issues. I use red Loctite on the overtravel screw. If I ever need to adjust it, a little torch action will loosen it right up for me. I would also recommend giving yourself some margin. Don't adjust it to 0 overtravel. Installing a lighter trigger return spring may result in an unreliable reset. Polishing may be needed to maintain a reliable reset. Polishing could lead to an increased risk of corrosion if you don't oil your gun well. Depending on the application of the pistol, I wouldn't do any of these modifications. You'll void your warranty, reduce factory operational and safety margins, and possibly reduce reliability. I reduced creep from 2.5 to 1.5 millimeters for a 40% reduction. I reduced overtravel from 2 millimeters to 0.5 millimeter for a 75% reduction. I think I could have safely reduced these a bit more, but I like to prioritize reliability and give myself some operational margin. I adjusted overtravel to 0, then backed the screw out a half a turn, and I only took 15 thou off the sear face. I reduced reset distance by about half. I could reduce this further by reducing creep and overtravel a bit more. I didn't like the feel of the Rain 6 trigger return spring. It was too light for my taste. The reset was tactile and reliable, but I liked the trigger to force my finger back out a little more. I installed the 19-pound trigger return spring that I bought from Century Spring, and the take-up dropped slightly. I installed the Rain 6 sear spring. My final take-up weight is 2 pounds, and my final break weight is 4 pounds. The creep and overtravel reduction made the biggest difference in this trigger pull for me. I didn't like the long rolling break, and it had a ton of overtravel and a long reset. I wanted to reduce take-up weight and break weight a little bit. It was also gritty as hell. The polishing made it feel much nicer and really complemented the other work I did. I achieved what I was after, and the improvement in trigger action is night and day compared to factory in my opinion. This trigger is really good for a striker-fired pistol now. It's right up there with my favorites, the Overwatch Precision trigger in my CZP-10 and the Apex trigger in my M&P 2.0. I have tried to make this the most comprehensive video out there on improving the Archon Type B trigger system. If you think I've achieved that, or if I missed anything, you can let me know in the comments. Now that I've done this work, if I needed to do it again and didn't have to fuck around with sourcing and testing springs and filming all this, I could probably get it done in about an hour and a half. This trigger system isn't that complicated or different to the point it makes working on it extra hard. A 1911 trigger job would take me longer than a trigger job on this. If you aren't comfortable doing any of this work yourself, I would consider Rain 6. I was impressed by their customer service, responsiveness, and willingness to go out of their way to help me. I don't have any experience with their firearms, upgrade packages, or services, but I have heard great things about the quality of their work from some viewers who commented on my previous Archon videos. I want to make something clear in case it's not. I'm not affiliated with any company like Century Spring. I'm not trying to sell you anything. I don't make money off this channel. I'm not offering Archon Type B trigger services. This is for educational purposes like all my videos. I hope you learned something. I hope I have provided useful information or given you ideas about how you can get more performance out of your Archon Type B trigger. As always, thanks so much for watching. I'll catch you next time.